Stated Clearly presents... What are atoms made of? As we learned in the last animation, the word atom means uncuttable, and when John Dalton first discovered evidence that atoms exist, he gave them that name because he genuinely thought that they were uncuttable. He thought they were fundamental particles, the smallest bits of matter that exist. Well, it turns out that he was wrong. Atoms can be split apart. They are made of subatomic particles, most importantly, electrons, protons, and neutrons. Protons and neutrons appear to be made of smaller particles still, and truth be told, we don't know for sure if there really is an end to smallness. Reality might just keep going on forever and ever the further you zoom in. So, there's something strange to think about. This image was made of data collected from an actual scan of a single nitrogen atom fixed to a metal surface. What we're actually seeing here is the outside of what is called the electron cloud, the outer edges of the atom. The colors here are artificial, but this is the real shape of a nitrogen atom. Here to the right, we see a simplified model of the same nitrogen atom. This type of model is called the Bohr model, named after the physicist Niels Bohr. Other models do exist which are more accurate, but when first being introduced to chemistry, the Bohr model is the easiest to make sense of, and so it's what we will be using here. In the center of a nitrogen atom, we have the nucleus. Looking over at the scan, you might think that the red section is the nucleus. That's actually not the case. As mentioned, the colors here are artificial. The red pixels are just the part of the electron cloud that's closest to us. The nucleus is hiding underneath the electrons. It is the core of the atom. And in our model, the nucleus has been dramatically enlarged so that we can actually see it. If the model were actually drawn more to scale, the entire nucleus would be smaller than a single pixel on your screen. In fact, if we were to enlarge the atom to the size of a professional soccer field, well, actually the size of 10 professional soccer fields, the nucleus would be about the size of a house spider. The nucleus consists of one or more protons, and in most atoms, a collection of neutrons. Protons and neutrons are what give the atom most of its weight, or its mass, technically. For example, a gold atom has 79 protons and typically 118 neutrons. This is far heavier than a nitrogen atom, which only has 7 protons and usually 7 neutrons. The number of neutrons in a particular type of atom might vary between individuals. For example, while most nitrogen atoms have 7 neutrons, some have just 6, while others have 8. Changing the number of neutrons inside of an atom won't really do much to change its chemical properties. Instead, it will often just make the atom slightly heavier, slightly lighter, or sometimes it will make the atom unstable. On the other hand, if you were to add or subtract just a single proton from nitrogen, assuming you had the technology to do so, you would completely change its chemical properties. So much, in fact, that we would no longer call it nitrogen. Adding just a single proton to a nitrogen atom would transform it into an oxygen atom. Taking a proton away from nitrogen would transform it into carbon. In other words, the number of protons an atom contains determines the type of atom it is. When you look at the periodic table, you find that each element has a number. Hydrogen is number 1, nitrogen is number 7, gold is number 79. This number tells you how many protons a single atom of that element contains. Protons are positively charged, neutrons are neutral. Obviously, they don't actually have little faces on them, but it helps to remember. Electrons, on the other hand, are negatively charged. We often depict them as little particles in orbit around the nucleus, similar to planets orbiting a sun, but this is not technically accurate. Scientists tell us that electrons can be best described as wave functions. Cloud-like structures that sort of resemble the energy force fields you might find in a science fiction movie. That said, for our purposes today, the simplified model actually works best. In general, the number of electrons an atom contains is equal to the number of protons in its nucleus. This is because each positively charged proton attracts one negatively charged electron. Through chemical reactions, however, an electron can sometimes be stripped away from an atom, or an extra electron can sometimes be added. In these cases, we call the modified atom an ion. Okay, that was a lot of information thrown at you in a very short amount of time, so let's just recap here and summarize the most important bits. What exactly are atoms made of? In the center of an atom, we find one or more protons, and in most cases, we also find neutrons. Protons are positively charged, neutrons are neutral. The number of protons an atom contains determine the type of atom it is. Hydrogen has 1 proton, nitrogen has 7, gold has 79, and so on. Orbiting about the nucleus, we find negatively charged electrons. In general, the number of electrons an atom contains is equal to the number of protons in its nucleus. This is because each positively charged proton attracts 1 negatively charged electron. I am John Perry, and that was a basic overview of the anatomy of an atom stated clearly. This animation series was made possible with a grant from the National Science Foundation and the Castle Research Center at the University of California, Irvine. Castle researchers are the ones that took that really cool image of nitrogen that I showed you, and a bunch of other images I'll show you in future videos. Aside from taking pictures of atoms and molecules, the researchers at Castle also produced a free video game called Bond Breaker, which teaches players how atoms and subatomic particles interact with one another. Though it is a fairly simple game, I have found it extremely helpful when trying to make sense of the strange properties that atoms and subatomic particles possess. I highly recommend checking it out. A link to the game is displayed here on screen and can also be found in the video description. This video was, of course, also funded by good people like you, who support my work on patreon.com/statedclearly. Thank you, folks. You are amazing. So long for now, everybody. Stay curious. Also, you should probably subscribe to this YouTube channel, and maybe if you feel like it, you can buy a t-shirt. There's links below the video.